So this is the system of equations from this video, and if you guys haven't seen this video, the link is in the description. In that video, some of you guys didn't think that this is possible, because if you graph this, you get a line. If you graph this, you get a circle. The line and the circle do not intersect. True that, however, we can still solve for this system of equations. We just have to use complex numbers. So to start, I will use substitution. Let me isolate A. So I will subtract B from both sides. Then we see that A is equal to 3 minus B. And I'll put this right here. We get 3 minus B squared plus B squared. That's equal to 4. And then expand this. We get 3 squared, which is 9, minus 2 times this and that, 6B plus this squared, B squared, and then another B squared here. And that's equal to 4. Then I will just clean this up a little bit. We have 2b squared minus 6b. Subtract 4 from both sides, we get plus 5, and that's equal to 0. Unfortunately, this quadratic equation is not factorable. And yes, we can just use the quadratic formula, but I'm not going to do that. If you're thinking about that I will be using the completing a square method, yes, but not the usual style. Check this out. Because usually, to complete a square, we want to have a 1 in front of the b square. Then in that case, we will have to divide everybody by 2 and then proceed. But the problem is that we will end up with an odd number, -3 here. Later on, we will have to take half of -3. You get a fraction and then square that. Yeah, I'm not going to do that. I want to give you guys something special, still complete the square. We'll do it this way. Multiply everybody by 4a. A is the leading coefficient here. So in this case, it is 4 times 2, which is 8. I will multiply everybody by 8. Have a look. 8 times 2 is 16. And then b squared. And then minus 48b. 8 times 5 is 40, but let me bring that to the other side. Leave a space, and that's going to be minus 40. Now, why did we do that? The truth is, now this right here is going to be a nice perfect square. If you look at this, this right here is the same as saying 4b and then squared. Now remember, here we have a minus 48b, but we want to break it down into minus 2 times this and something else. Well, this is just 4b. So now let's think about it. 2 times 4 is 8 already. We need to produce and get 46, which we need a 6. I told you guys the answer. Anyways, we need a 6. So that altogether, 6 times 4 times 2 is 48. And then along with the b. So here, we better have plus 6 squared. And we do that to both sides. So that's just another style of completing a square. Now have a look. Something squared minus 2 of the first times the second thing squared. We can factor it nicely. This is going to give us 4b minus 6 squared, and that is equal to this right here worked out 36 plus negative 40, which is -4. And we continue. Take the square root, both sides. Don't forget a plus minus, cancel this out. So, ladies and gentlemen, I want to isolate the b. That is going to be equal to, here we have plus or minus, negative in the square root, we get I. So that's square root of 4, which is 2, 2i. We have plus or minus 2i from here. And then I will have to add 6 to both sides. So that will be a positive 6 here. And then we have to divide the 4 right here. So that's what we have. And we can clean this up a little bit more. You can see that we can factor out a 2 on the top. So that's 2, and then 3 plus or minus I, and then we can reduce this. This is 2, this is 1. So in fact, b is going to be 3 plus or minus I all over 2. Now to figure out the a, we have two choices. A is equal to 3 minus, the first b is 3 plus I over 2. Okay, let's get the common denominator, which is the 2 here, 2 here, so that will be a 6. And then we have to distribute this. 6 minus 3, we get the 3 minus I, and then the same denominator over 2. Similarly, A is equal to 3 minus the other choice for B, 3 minus I over 2. So same thing, multiply by 2, that's a 6. Same thing. You get 3 plus I over 2. Now finally, this is how I'm going to write down the answer. I'm just going to put it as an order pair answer. When A is equal to this, 3 minus I over 2, B is equal to that, so it's 3 plus I over 2. Remember, this is the A, this is the B. Or the other one is we have that, which is 3 plus I over 2, and that's when B is equal to 3 minus I over 2. Yeah, just like this. So this system of equations does have solutions, but it's just in the complex world. That's it.